starting. All right, so standard form or scientific notation, and it's our scientific way of writing very, very small numbers and very large numbers in a notation or in a concise way. So a times 10 to the nth power. This is the format. A times 10 to the nth power, where a is a number between 1 and 10. So a must be between 1 and 10. All right. And a can be 1 though. So again, scientific notation, a concise way of writing very large and small numbers in a concise way. All right. A must be, I'm talking about a here. This a here is referring to this a must be between 1 and 10, and it can be 1. Okay. Anything else? Yes. N is a, or I can say a is an integer. Typically denoted by the letter Z. So a is an integer, meaning a whole number.
Natural numbers.
Well, it's a whole number, and let me just put it more easy. Okay, it's not really a whole number. Well, it's basically any number which is a whole number with a plus sign in front of it or a negative sign in front of it.
Okay.
Yeah. So we can actually say positive and negative whole numbers. Whole numbers are not negatives, by the way, but we just simply saying negative whole numbers mean you can have a negative in front of the whole number. Okay, so we can say it's a positive or negative whole number, including 0. Okay, it can also be including 0. It can also be 0. Okay, I think that's it. Let's look at some examples. 0.005, and let's look at 500. Writing these in scientific notation. Okay, so for instance, this number, let's start with the bottom one, 500. That can be written as what in standard form? Tell me what you think that is in standard form is.
It will be 5 times 10.
What power?
I know what power.
Okay, let me ask you a question. 5 times what give us a 500? 5 times what give us 500?
Huh?
1 second, 1 second. Okay, so we said 5 times what? Give us a 500? 5 times what number?
50.
5 times 50. 5 times 100 would be what?
5 times 100. 5 times 100 is what?
Yeah. 5 times 100. Like saying you have 100 5 times.
500. So
Right. So 5 times 100 is actually 500.
500.
Yeah.
Yeah.
So 10 to the first power is actually 10. 10 to the 0 power. And this one is probably a little strange. 5. Okay, let me see if we can actually. Okay, 10 to the 0 power is actually 1. Right? Any number to the 0 power is 1. Then we can say 10 to the 1 power is 10. And it's making sense, right? We start with 1, then we add a 0.
10.
Then we have 10 to the second power. What that would be?
20.
We're going to add another 20, but we're going to add another 0. 100.
We come and just add zeros.
Yeah.
Oh.
You see, when you reach here, it's like saying 10 times 10. with the 10 to the second power. In fact, it does
Oh,
mean
10
that.
times 10, 10, 10 times
So
10, 10 times. Yes, okay, I get
so
it now. I
10 to
get
the
it now.
second power is really 10 times 10, which
10
is
is really
100.
100.
Yeah.
Yes.
And we
Yes.
have 10 to the third power, which would be what? It will mean 10 to the third power would mean 10 times 10 times 10.
Okay. Yeah.
So that will be what? It's gonna be, you have three quantities of 10 multiplying, or three factors of 10. So you count the number of zeros, 1, 2, 3. So that will be 1 with 3 zeros. Right? So that will be 1,000. If you look at it, how many zeros we have in this? Okay, let's look at it here. Think of the power as saying the number of zeros. All right. What power we have? We have 0 power here, right? We have 10 to the 0 power. So we have 0, 0 zeros. In other words, we don't have any zeros. So we have a 1 there, right?
One.
The 1
Yes.
here indicate the number of zeros we should have. How many zeros we have here?
1.
Okay,
Which
2
one? The
tell us
second
we
one you
have
talking
2
about? Oh,
zeros.
yeah,
We have,
two zeros, yeah.
there's 3 tell us we have how many zeros we have. 3 zeros, right?
2 zeros. 3 here.
Right. But really, it doesn't really come from that per se, because something like 2 to the second power doesn't mean we have 2 2s, right? It simply means 2 times, well, it does mean we have 2 times 2, but it doesn't mean we have 2 2s. Like 2 to the third power doesn't mean we have 2 3, doesn't mean we have 3 2s, but it means we have 3 2s multiplying. Like for instance, 2 times 2 times
2
2.
times 2.
Right. Okay. So in this case, we have 110 is in 10. We have just anything to the 0 power is 1. Just remember that. 10 to the 1 power, every quantity is written to the 1 power. Still gonna leave at that same quantity. For instance, 2 to the 1 power is still 2. 5 0 to the 1 power is still 50 or 50. Yeah, 7.5 to the, okay, sorry about that. Just keep on. Yeah, 7.5 to the first power is still 7.5. So anything to the first power is still that quantity. All right, it's still the same quantity. Anything to the 0 power though is gonna be 1. That's a lot of information I'm giving you. But just remember that. If I have 10 to the 0 power, it's 1. If I have 11 to the 0 power, it's still 1. If I have 12 to the 0 power, it's still 1. If I have 50 to the 0 power, it's still 1. Any quantity to the 0 power is going to give you 1. Okay? Now, once you have a power other than 1, more than 1, it means that you're multiplying by that quantity. For instance, 10 to the second power means 10 times 10.
10.
12 to the second power means 12 times 12. Yeah. 4 to the third power means what? 4 times 4 times 4. Yeah. How many factors of that quantity you have? How many times that quantity is multiplying by itself? Okay?
Yeah.
So we have 10 to the second power, 10 times 10, and we know 10 times 10 is 100. 10 to the third power means 10 times 10 times 10, which is going to give you 1,000. 10 to the fourth power is going to be what? 10 times 10 times 10 times 10, which is going to give you 10, right? Sorry, 10,000. Or 1 with 4 zeros. Hopefully that was helpful. Do you think you get the hang of it?
Think so.
Okay. How many zeros are we going to have with 10 to the fifth power?
5.
Very good. As easy as that. So we have 2 zeros here. So what power of 10 that should be?
2.
Right. Good. Very good. All right, let's try another one. This should be what? 9 times. 9 times what give us 9,000?
100.
Right. 9 times 100 would be 900. So it's going to be 9 times what? Not 100, but 9 times what?
It's 9 times to the third.
9 times 10 to the third, or 9 times 1,000, right? 9 times 1,000 give us 9,000, which is going to be 9 times 10 to the third. Very good. All right. So this 10 to the third is the same thing as 1,000. This 10 to the second power is the same thing as 100. So I want to see the link between them, right?
Yes, I'm seeing the link actually.
Okay. Now let's look at this now. Here's how we can think about it in a different way. All right. If I have 500, where's the point in this number? If you were to write 500 in a calculator and press equal, you're going to see the point where?
After the 0.
Right here. So if we want 5 times 10 to some power, in order for me to get the 5, where would I need to put this point?
To get the 5?
Yeah, to get 5. To make this number here, 5, where do I need to put the point?
Before the 5?
Before the 5, right? Right here, you mean, right? Right there? So that's what you mean, right? Because it's now
Yeah, right there.
5.00. And think of this as like $5.
Yeah.
Still 5, right? In
Yeah,
value.
yeah.
Right. So the point was at the end, but now we move it and put it there. So basically, we move 2 places inwards. But the idea is that we would have moved 2 places. So the power has to be 2.
-2.
But not -2 though. I know I think about the movement to the left and so forth, but I don't usually think of it that way because you see the thing is, if you put -2, then this will not give you, when you work it out back, you're not gonna get 500. All right, it's gonna be +2 because this, or think of this original number did not start with 0 point something, so it's always
That's
gonna be
what. Okay, yes.
if you start with, once you start with 0 point something, it'll be a negative power.
Ah,
That's what quicker way to remember it. So this number did not start with 0 point something. This number is larger than 1, so it's gonna be a positive power.
0. If it starts with 0, it's gonna be a negative.
Yeah. So if the number is larger than 1, the power is going to be positive. If the number is smaller than 1, it's going to be a negative. For instance, this number here is larger than 1, so it'll be a positive power. Positive power. This one is smaller than 1, in other words, 0 point something, so it's going to be a negative power. So it's a quick way to remember it.
Negative.
As long as it starts with 0 point something, negative power. If not, positive power.
Positive, okay.
Yeah. All right, I'm giving you a lot of information in such a short time, but
I know that. That's helpful. Yep.
I know you'll grasp it by just swinging you all over the place with content. Okay. Something has to hit you so you can understand it. Okay, good. So again, we would have moved right here. So it's now 5.00. But these two are not the same. So I can't put equal here because 500 is not equal to 5. All right, 500 is not equal to 5. These two, so I can't put the equal sign in. For me to put the equal sign there, I must multiply it by a power of 10 to bring this 0, this point at the end. So I multiply by 100. 5 times 100 will give me 500. In other words, the point moves 1, 2 places to the right. All right, which is the same thing as saying I can ignore these zeros and put 5 because they mean this has the same value. So still 5, still 5. And I can rewrite 100 as 10 to the second power, which is 10 times 10. And 10 times 10 is 100. So this is standard form. It's a number between 1 and 10 multiplied by a power of 10. This little 2 raised in the air is a power or index or exponent. So you have several names: power, index, exponent. So it's a power of 10. All right. So I think you got that right? Yeah. Okay, awesome. Okay, so let's look at the other one though. The other number, 0.005. Oh. Again, it needs to be a number between 1 and 10. So what's the first digit we're gonna write? The first digit, 5 again. So is 5 between 1 and 10? Think about $5. Is it between $1 and $10? Yep. Right. Times the power of 10. What power of 10 do?
1, 2, 3, -3.
Brilliant. You see? So we're gonna go 1, 2, 3. 3. Right there, the end. Okay, so if I have 0.0504, what would that be? No, you have to include all non-zero digits. So if there's a 0 in between non-zero digit, you put it in. If there's a 0 between non-zero digit, put it in. So Of course, we're going to write the 0 here because this 0 is between two non-zero
Yes,
digits.
numbers.
So we have to
Today,
put our 504.
504.
Yeah. But where would the point go, though? Where would the point go? Remember, the first part has to be between 1 and 10. Think of money. Where would you put the
Between the
point?
5 and the 0.
Between the 5 and the 0. Excellent. So it's like $5.04.
Cents.
So it's between 1 and 10, right?
Yeah.
Times the power of 10 times the power of 10. What power of 10 would that be?
1.
Huh? Now think about this number. This is the number you're looking at.
1. Oh, okay. 1, 2.
1, 2, right. But is it going to be positive 2 or negative 2?
Negative.
Negative. You see, if it's positive, that you have to move to get back the original. For instance, let me show you something quickly. 5.04 times 10 to the second power. And 5, okay, 1 second. And 5.04 times 10 to the negative 2 power. Right? With the positive power, if you want to get back the original number, because it's a positive power, you have to move the point to the right. Right? So you have to move the point here to the right. Why move it to the right? Because this power here is what? Positive.
Positive, yeah. To the right is positive.
So the answer will be 504. So 5.04 times 10 to the second power, which is really 100, is going to be 504. While 5.04 times 10 to the negative, it's negative, so negative power, is not going to be 504 because because it's a negative power, we have to shift to the left. 1, right?
1.
And then we shift again, 2.
2.
So the point going to be here, so put a 0 in there. Put 1 here as
Which
well.
is,
So it's going to be what? 0.504. All right, which is the original number that we have here.
Yeah.
Got it?
Got it.
Okay. So let me see something there. Okay, let's see if we can move over to you're over to the new screen, blank screen.
No.
Okay.
I'm still seeing what we're working on just now.
Okay. Do you see a little page number down below somewhere or anywhere?
No.
No. Look somewhere on the all over in the corners. If you see anything, you can press.
Oh yes, page, yes, blank, yes.
Okay, all right, awesome. Okay, let me just give you something quickly. Let's say we have this.
66.816.
Okay. Oh, I was giving you something to do quickly. All right. All right. Write this in ordinary numbers for me. Give me the answers to these. Ready?
1, 2, AB. The first one?
Yeah. What would we do? Where would we move the point?
Negative.
To the left or?
We're going to the left.
Okay, so how many parts?
1, 2, 3. So it will be 0.03.
Go again.
3.
Point.
0.0303.
Good. And we can put a 0 here, so this point don't run away, right? Well, it's really the whole number section. Yeah. This is a decimal section. This is a whole number section. All right, let's do this one down here. So that's correct. Let's look at the next one. 2. Ready?
We're going to the right.
Okay, to the right. Okay. So one place to the right we're going.
1 in front of the 5 and 2. So it'll be 5, 4, 5, 0.
Let me do this properly. My bad. We're gonna go 1 and then what? 2. Okay. So what we're gonna do here? So point goes here.
What is, yeah, point goes there.
And a 0 go here, right?
0 go there. Yeah.
Okay. So it's gonna be 5.
4, 5, 0. Point. 0, 0.
5, 4, 5, 0.
0. Point.
And that's it, right? We can put a
Yeah.
point here, but
Yeah.
since at the end we can ignore it.
Yeah.
And so that's correct as well too. All right. And what about this one?
We 1.3105.
So we go 1, 2 place to the left, indicated by the negatives. So 1.3105. Okay, good. Next one.
50.
Right.
Point.
So go 1, 2, 3, and then 4. So put a 0 here. So we will ignore all these zeros then.
Yeah.
Since the point is now in front of a non-zero digit, and put 5, 0. Very good.
0.
Okay, awesome. All right, so let's move on now. Well, let's go back to this. Let me go back to the one that we were on a while ago. What did you say? What did you say?
It was 6.816.
66.816.
16.
And we want to write it in what?
Standard form.
In standard form. So that would be what? Remember, it has to be what? A times 10 to the n power. A must be between 1 and 10. Keep that in mind. The figure where we have to move the point, so it's between 1 and 10. And n must be an integer, like a positive whole number or negative whole number. Could also be 0. Okay, so
Yeah.
it's 0 if you don't have any movement, you know? So if, for instance, if somebody asks to write this in standard form, 3.1 in standard form, that would be 3. It's already a number between 1 and 10. So it's 3.1 times 10 to the 0. Because you're not going to have any movement. Remember, 10 to the 0 is 1, you know. So it's like saying 3.1 times 1. Anything times 1 give you back that same thing. So it's like saying multiplying by 1. Since 10 to the 0 is actually 1. So 1 times 3.1 is the same thing as 3.1. That's why it's okay to just write it like that. But we don't have any movement since 3.1 as a number is already between 1 and 10. So we don't move it. That's why the power is going to be 0. Okay, so let's go back to this down here now. You say it's going to be what? Tell me what to write first. The number that's actually a number between 1 and 10.
But this number is between 1 and 10. The 6 between 1 and 10.
This number here that we have here?
Yeah.
No. It's definitely not between. If you put money here, I'm a dollar sign. What number? This number is not between $1 and $10 at all.
So you use back the same number?
No. This number I'm talking about down here now. What call this number for me?
66.816.
Right, call the first part before the point.
66?
Yeah. Is 66 between 1 and 10?
Nope.
That's right. So where would you have to put the point? So it's between 1 and 10.
Between the two sixes.
Right, brilliant. So you put it between the two sixes and put out the rest, right? But these two numbers are not equal because one is 66, are close to 66, which is close to 67. And this one is just 6.6, which is close to 6.7. So in order for me to keep the equal sign, I need to multiply this one
times 10
by a power of 10. Very good. Times 10 to what power?
negative. No, yeah, negative 1.
Yeah.
Yeah,
negative 1. Very good.
Left. Yes, negative 1.
Hey, man. Yeah, you got it. Very good. You had gotten it correct, by the way?
No, because you know what? I didn't know what to do. I didn't understand it.
You didn't do it. Okay.
Yeah.
Yeah, I remember. I think you didn't do it. Yeah. All right, but you get it though, right?
Yeah, I get it.
Okay, brilliant stuff.
You have to get the number. You have to get this first number between 1 and 10.
Yeah.
And then you multiply it, the negative or positive, how much times you move the point.
Yeah. Right. If you have to move the point to the right,
It's positive.
well, no,
It's
no, no,
left.
no. Let me back that up. If it is that the
It's up.
the number is 0 point something, the power will be what? Negative, right? And if it's a,
0.
yeah. So this number didn't start with 0, so it's being negative. Would it? No. We're wrong. Yeah, that's not looking at it. This is wrong. It
Is
can't be a
wrong?
it can't be a positive one, negative one. You see, when you go back to the rule, you're right. It can't be negative one. Why it can't be negative one? Let's go back to these up there. Like when this is negative 2, you see what we do with the point? We move it to the what? The left. So that means if we look at this number here, we'd have to move this
The
point
left.
to the left to get back the original number. But it would not give us back the original number. It would give us 0.66816. So where it has to be?
Yeah.
You're right. So it has to, instead of negative one, it has to be what?
Positive one.
Positive one. Very good. I wasn't even thinking. But it's good that we touch on the principle. You see
Yeah,
what I said
that's
there?
better.
If the
So
number,
you work it back out to make sure you get back that number. If more positive
yes,
going right, so yeah. Okay. Yeah. So get it.
yeah.
Get it.
If you multiply 10 to the 1 is 10, 10 to the 1 is 10, right?
Yeah.
And if you multiply 6 by 10, you get 60. So it's really mean that you move the point one place to the right. So it's 66. So that's correct. 10 to the 1 power. Got it now?
Got it.
If it was like this though, if it was 0.66816, what would it be in standard form?
You're moving the decimal place to the right.
To be 6.6, one
8.
place to the right, right?
Yes.
So 6.6816,
Eight
just like
one
this
six.
one up on top there. But
Mm-hmm.
the power of 10 will be different. What would it be?
It could be -1.
-1. Very good. Because if you
And get it.
ignore this number, here and just focus on this one that you're given over here as an expression, because the power is a negative power, you have to move this point one place to the left.
Okay,
And it will
yes.
actually give you back this original number here. But I think you can remember, just remember that if the number start with what? With 0, the power will be what?
It can be negative.
Yeah, so keep that in mind. If you start with 0, right? Right? The power will be negative.
We say you have classes?
Hmm?
We say you have classes? Or when you have classes and where?
Oh, I just teach at a school. I don't, well,
Oh, you
I'm
just start
supposed,
classes yet?
yeah, I'm gonna start probably this week coming up with some adult learners who want to write CXC, or so anybody that probably just didn't pass recently that can work too. But the regular school children, I'll have it with them after school that I'm teaching.
And all this should be involved?
Yeah, yeah. These are all part of CXC. You have to learn all of this and much more. I don't think your coursework would cover everything in CXC. CXC is very wide. There's a lot of topics. But if you want, you can always join, no problem.
That's
But
what I'm
I
thinking.
will
When
all,
would I have time though?
huh?
All my classes are night classes.
Oh yeah, understand. No problem. All right, what was the other thing you wanted help with?
Do 3. Let me see if I did 3 correctly. I'm not
Hmm?
sure if I did 3 correctly. I'm not sure if I did 3 correctly.
Okay, let me check out 3 then. 1 second.
We have to convert the
Okay, so we'll record this. Okay, go ahead now. What we're saying?
we have to convert the 1/4.
Okay, right. So with this now, you do brackets first, right? You
Yes.
have to remember BODMAS. The thing is that these two and these two, whichever comes first. If division comes before multiplication, you do that. If multiplication comes before division, the multiplication. So these are technically on the same level. And addition and subtraction, you do whichever you see come first. Once it comes first, I mean going from left to right. But you always want to do brackets, also known as parentheses. Work those first. And then off, it's like multiplication, but you do that first. And some people say use this bed mass. So they remove the O, because O is like multiplication anyways. You can just change to multiplication. But they use bed mass. So what they're saying here is that this is exponent, also known as powers. Right? This is brackets. Or parentheses. And then you have division or multiplication, then addition or subtraction. Whichever comes first. So these, we don't really go in this order, B-O-D-M-A-S. It's just when we reach D and M, whichever comes first, which A and S, whichever comes first. So addition and subtraction, A-A-S, and division multiplication, D-M. Okay, so we're doing brackets first. I'm going to put back what we're not using. Always remember that. And as you mentioned, you're going to convert from mixed number to improper fraction, right? One of the easier ways to work things out. So we're going to say 4 times 1. So we're going to say 4 times 1 plus 1 over 4. Now, I'm doing it like that so you can actually see what's happening, but I'm sure you're familiar with that already. Okay. Right? So this 4 here in the denominator multiplies the whole number, and you add the numerator 1. All right? So, in fact, what you really have there, what is 4 times 1 plus 1? That's 5, right?
5, yeah.
Okay. All right. And so what we do next, we're going to just basically try to get like denominators. They have different denominators, so you can't subtract one from the other. So to get them to become like denominators. All right. So one way you can do this, there's so many ways of doing this. But let me just explain it from this point. The LCM of 4 and 8 is 8. You're familiar with that, right? Because 4 can go into 8 and 8 can go into itself.
Yeah.
I'm going to say 4 goes into 8 twice. And that will give us 10. The same amount, 4 goes into 8 twice, you multiply by the numerator. Put the 5 there. So in fact, what we're really doing, is saying 5/4. We can write it in another way, which is 10 over 8. So 5/4 can be written as 10 over 8. That's all it's basically saying. So we have, 5/4 as an equivalent fraction. We just multiply the denominator by 2. And what you do to the denominator, you do to the numerator. So in fact, what you have there is 10 over 8. So now you have 5/4, which is really what? 10/8. And you can actually say 10/8 minus 5/8 will give me how many 8s? If you have 10/8 and take out 5, and take out 5/8 from 10/8, you'll have a remaining of 5/8. Right. So you got that, right? So what we have here is really 2/3 multiplied by the results, which is what? 5/8.
5/8.
And then what you do here, you're gonna say 2 times, well, you can simplify this further, right? You can simplify this further. Let me show you how we do that. We look for numerator and denominator. Look at this numerator and look at this denominator. Once you can cancel, you cancel. So we can say 2 goes into 2 once and 2 goes into 8 4 times.
4 times.
Now we can't cancel any further, so we multiply right across, right? So we're going to say numerator times numerator, which is 1 times 5 give us 5.
Right.
And 3 times 4 give us
12.
That's that. 5/12.
I didn't get that at all.
All right. So just remember though, that what I did here, if you want to write it down, if you ever want to have it written down, you can say, okay, well, we multiply this by 2, multiply this by 2, right? So this is actually saying 10, 5 2s is 10, right? And 4 2s is 8. So we're saying 10 minus 5, and that would be 5 over 8. Remember, you keep the denominator. So it's 5 minus 5. So you're subtracting the numerators only. Sorry, 10 minus 5, I should say. 10 minus 5, which is 5. And I keep the denominator, which is 8, because 4 2s is really 8. So in fact, what I'm saying is 5. 5 times, which is 10, over 8 minus 5 over 8, which gives me 5 over 8. And that's the answer.
5 over 8. Yes, you get that.
Yeah. And when you simplify numerator with denominator. When you're multiplying, you simplify numerator with denominator. So look for a number that can enter both numerator and denominator. If you couldn't, you multiply straight across. But in this case, we could have simplified.
You go ahead. When
Oh,
the one with the 4 and the 8, when the denominators are, if you can get, then alike, one half can go into the other.
yeah, but there are cases where they're not alike, and you just go outside. Okay, it's gonna end again, so we're gonna have to start over here. So we're gonna look at another example then in a different way.
Okay.
All right, let me see if I can stop this.